Hi everyone, and welcome to our video on the introduction to the basic derivative rules. So here we've got our derivative notations. This first one and the second one are the main ones. The way that we say this is f prime of x. The second one we say dy dx. So it looks like a fraction, but we state it just like that. So dy dx. So that's the derivative of y with respect to x. So derivative of y with respect to x. So that's the extra long way to say it. Then this third one is telling us we are going to do the derivative. So that's this part. Do the derivative of whatever this is inside there, of f of x. Okay, and so is this fifth one actually, but it's just not used as often. So these are the big three. Okay, and then the other two, df dx, is like the derivative of a function with respect to x, and then y prime of x is similar to the first one. Okay, so I think the main two are those first two, but we might see those others every now and then. All right, these are our basic rules in this table. So the first rule is saying the derivative of a constant is 0. So remember that a constant, so like say we had the equation y equals 5, we know that the slope of this line is 0 because it's horizontal. So the derivative is always referencing a slope of the tangent line. So all of these are trying to help with mtan, so slope of a tangent line. Well, in this case, the slope's always 0, so that's why the derivative of a constant is 0. Similar with the linear one, so here we have the derivative of cx, so let's just make one up. So here's a linear function, y equals 2x. Well, still, if it's line, we know that the slope on this problem would be 2. And so similar to over here, it's saying the derivative of c times x is just c. It's like this 2 right there. The slope is just 2. Okay, so those are special cases because they're lines. This power rule, so if x is raised to a different power than to the first, then we know it's curvy and the slope of the tangent line would change depending on where we are. So for instance, I'm going to squeeze that just right over here. So like a parabola has different slopes of tangent lines depending on where the point is. So we can go from a positive to a negative or even 0. Okay, so it changes, but there's a quick way to find it. So the power rule tells us the derivative of x to a p. Step 1, it's telling us whatever this p is right here, instantly just put in the front. Okay, so right power in front. And then the second step, look at that right there. It was p, now it's p minus 1. Then subtract, or then let's say then minus 1. That's a bad one. Then minus 1 from power. Okay, so those are the two steps to do our power rule. Then these other rules we'll see in the next couple problems. It's just telling us if you have a constant times a function, then that constant's just going to be there times whatever the derivative of the function is. Okay, so the constant's just kind of hanging out. So that's what happened in this step 2. This constant's just kind of hanging out times the derivative of the x. Okay, so that was a special case. And then this last rule is telling us if we have a function plus or minus another function and we want to do the derivative, it is the derivative of the function, the first function, plus or minus the derivative of the second function. So it's just telling us we can go term by term. Okay, so in previous videos, we had the full definition right here where I'm kind of swirling. We don't have to do that anymore unless they want us to, unless they say use the definition. However, if we're doing our derivatives quickly, we'll just use these rules. Okay, so let's try this group out. So it says find dy dx. Okay, so I'm going to show when I'm doing the derivative in blue. This one's set up already. So sometimes we might need to write a few steps before, but this is ready. And so our rule is telling us, well, we have a 20 as the power. So saying write that 20 in front right away, and then minus 1 from the power. So 20 minus 1 would be 19. And then that's it. That's our derivative. Okay, so power to the front, and then minus 1. Okay, so that's it. Super quick. Okay, let's see number 2. Okay, so this one is ready for us. So I'm going to keep this in blue. So dy dx, so the derivative of y with respect to x. Okay, so that 2/3 is just hanging out because there's an x attached to it. So what I'm doing, let's underline it, I'm applying the rule for our power rule on this x to the 9. So it's saying put a 9 in front of the x, so 9x, and then minus 1 from the power. So it would be 9x to the 8th. And then notice this, they're trying to trick us. 5 to the 12th, there's no variable in this term. There's no x, so that means it's a constant. So 5 to the 12th is just a random number. They're just trying to trick you. 5 to the 12th is a constant. The derivative of a constant is 0. Okay, so we're just going term by term. So the plus in between, so we're using that rule right there. We're just doing it term by term. The derivative of a constant is 0. Now we don't really need to show the plus 0, but I wanted to on that problem. Now we do need to simplify. So now I'm back. So that was the one step of calculus in the blue. And then now we just simplify. So that's why I'm back to black ink. Okay, and then, well, 2/3 times 9. So these multiply like normal. 2/3 times 9. However way you want to simplify it, and if you can use a calculator, you can plug it in. But 2/3 times 9 would be 6. And then x to the 8th. And then we don't need to show plus 0 anymore. Okay, so that's our derivative of y with respect to x in that function. Okay, so let's try these two as well. So it says find y prime. Okay, so y prime, so that's a different notation. So that's okay. So it's the same as dy dx if we want to write it like that instead. Okay, but we'll do y prime. So first thing though, so number 3 here is not really ready to go. We need to first rewrite that. Okay, so we have a square root. So we would want to rewrite that. So again, the h is there. And then x would be changed, or the square root of x would be changed to x to the 1/2 power. So the square root of x and x to the 1/2 are the same. Now it's ready for us to do a derivative. So let's write it as y prime equals, and then the 8's just there. Oops, let me keep it in blue. So the 8's just there. And then now we're doing our power rule to that. So it's saying put the 1/2 in front of the x, and then minus 1 from the power. If you need scratch work to the side, that's fine. It's still always minus 1 from the power. You can, if you can use a calculator, I mean, we could plug that in, and it simplifies to be negative 1/2. So this was just scratch over here. So this was just scratch work. So it's not super important. And if you're fine without knowing the scratch work, if you knew instantly 1/2 minus 1 is negative 1/2, then good. Okay, so that was the step. That was doing calculus. That was the derivative. And then let's write our final answer, y prime. Again, these multiply like normal. 8 times 1/2 would be 4. And then x to the negative 1/2 is the leftover power. Now that's usually fine. If they want us to change it because they don't like a negative power, we could rewrite it. So remember, a negative power is just to flip the variable and then make the power positive. So what I mean by that is we would have 4. So 4 is just left in the numerator because currently it's over 1, but we don't need to show that. But it is. So 4 over 1, we would leave 4 in the numerator. And then the x to the negative 1/2, we can flip and make the power positive. So it'd be x to the 1/2 down in the denominator. And then even here, if I wanted to rewrite it, if they're really forcing us to, x to the 1/2 we know is the same as the square root of x. Okay, so there's 2 other ways to write that final answer. Okay, so the first one should be fine, but if they don't like the negative power, then we would need to change it. All right, this number 4, it looks like it's good to go. Okay, so I'm just making sure like if there's square roots, I would need to rewrite, but this I have all the powers ready. So I'm going to say let's do dy dx equals, again, that 12 is just hanging out, and then doing the derivative rule to x cubed, 3 would come to the front, minus 1 from the power would be 3x squared. And then we'd have minus 3, and then now doing our rule for x squared, we would have 2 to the front, and then x to the first. So 2 minus 1 is 1. We don't need to show that 1. We will not in the next step. We'll clean it up. Even here, so this we had a rule for already. So this is linear. Okay, so we could just say, well, the derivative of a linear part is just the leftover constant. There we are. That part's done. And then the minus 9, that is a constant. The derivative of a constant is 0. Again, I'm just going to show it for this problem. Probably won't later on. Okay, and then afterwards, it's just clean up. So often it's one step of calculus and then clean up with simplifying the rest. So we would say, well, 12 would times 3 to give us 36. X squared's attached. This 3 and that 2 would be 6, still minus in front, so minus 6x. We don't need to put the little 1 there anymore, so minus 6x. And then plus 4 is ready, plus 4. And then that's it. That's as good as this gets. Okay, and I wrote dy dx. We could again change it to y prime. Okay, so we could have written as y prime equals whatever, or we could have done y prime of x equals that same thing. Okay, I'm just going to put squiggle because I'm out of room, but those are, again, the same notations. Okay, let's take a pause. We'll do some more right here in a second, but I think that's good for this video. These ones are a little different, and we'll pick it up then. Okay, thanks for watching. See you again next time.